Hello, welcome to the video notes for lesson 4-2. This begins on page 6 in your notes packet, and this is using scientific notation to describe very small quantities. So we're dealing with super small numbers. Our learning target: I can express numbers in standard form in scientific notation. So take them from standard form and write them in scientific notation, and express numbers in scientific notation in standard form. So going the other way around. What is scientific notation? Why do we need it? Okay, here's our first example. The mass of one oxygen molecule is 0.0000, well, you get the idea, lots of zeros. Find the mass of 10,000 molecules of oxygen in grams. So in order to do that, we would need to multiply this number, whatever it is, however you would say it, by 10,000. And that would not be an easy thing to do. And even by multiplying it by 10,000, this number is so small, it's not going to make it much bigger. Although I will say, this is not as difficult as it looks. Essentially, we would be moving this decimal over this way and getting rid of 4 zeros. But it's still, it's a difficult number to write and manage and deal with. So, another example below. A microscope is set so it makes an object appear 400 times larger than its actual size. Now that sounds like we're dealing with something really big. But the reason why it's multiplying by 400 is because it's so small. A virus has a diameter of 0.00002 centimeters. How large will the diameter of the virus appear when it is viewed under a microscope? Again, we're dealing with very tiny numbers. Now, this is actually not a difficult problem to do. We would just simply multiply this number by 400, and we would get 0.008 centimeters, or 8,000ths of a centimeter, which is a very small number. Again, not very practical and easy to work with. So that's why we have scientific notation for super small or really, really big numbers. This lesson is all about dealing with those really small ones. So let's take a look at the next page, page 7. And we have our definition. This definition is the exact same as the one from the previous lesson. A number in scientific notation is written as the product of two factors in the form a times x 10 to the nth power, where n is an integer, so a positive or negative number, and a is in between 1 and 10. It can be equal to 1, it cannot be equal to 10. And then we have 3 examples, the same 3 we had before. Okay, I want to put a special note here. Write this down, make a star, make it better than mine. It's okay to leave the negative exponent. So we are going to have answers with negative exponents. Alright, so express the number in scientific notation. So, again, we want the decimal to be in between the 3 and the 2. So I'm going to write 3.2 times 10 to some power. Now, because we're moving it this way and we're dealing with a super small number, it's going to be a negative exponent this time. And I count the spaces, 1, 2, 3, 4, 5. So it's going to be negative 5. The next example, again, where do I want the decimal? Well, if I put it between the 5 and the 6, I'd get 45.6. So that's not going to work. So put it in between the 4 and the 5, and you get 4.56. Don't get rid of that 6 or round it, times 10. Now it's going to be a negative number because we're, again, dealing with a super small number. Count the spaces. If you like to do loops because it's easier, that's fine. So 2, 3, 4. So times 10 to the negative 4. All right, let's do one more. All right, so this decimal needs to end up all the way over here on the other side of the 9. So we end up with 9.0, or just 9, times 10 to some negative number. Count the number of spaces and write your answer here. I'm not going to do that for you. You have 2 more to finish, 4 and 5 on your own. Remember, you're going to want to move your decimal so you make your first number in between 1 and 10, and then you're going to multiply it by 10 to some negative exponent. Okay? So finish 4 and 5 on your own. I'm going to clear the screen, so pause it if you need more time. Okay, now we have 6, 7, 8, and 9. I'll do the first 2 and then let you finish on your own. Write the number in standard form, so now we're going to go the other way. Alright, so I have a negative 4 here. So that means if I take my 3.2, the negative 4 tells me my decimal is going the other way this time, 4 spaces, which means I'm going to be adding 3 zeros, actually 4 zeros, and putting a decimal in between the 2 on the end. So my final answer is 0.00032, or 32, is that 100,000? Okay, so let's do the same thing with number 7. I'm going to move it over 1 and add 1 0. But that 0 is going to be on the other side of the decimal. And write the rest of the number, and you are done. So I want you to try 8 and 9 on your own. See how you do. If you have trouble with it, don't get upset. Don't get frustrated. Let's go ahead and just take a look at the next page. I'm going to have you do these examples on your own on page 8. Up at the top. However, I want to take a look at number 8. Which number is larger? So we've got 8 times 10 to the negative 5, or 8 times 10 to the negative 8. I'm going to write it out so you can see it, but I think some of you who are understanding this will know already. So I have a negative 5 exponent, so I'm going to write 8, and I'm going to put 5 zeros in front of it. And I put a decimal in between the 2 on the end, so technically there's 4 zeros. Or I have 8 and times 10 to the negative 8, so I'll do 8 zeros, put my 8, and then put a decimal in between the first 2. So what do I have here? Which one is bigger? Now, I know you might say, well, this one has more zeros. That doesn't make it bigger, it actually makes it smaller. So technically this one is bigger. To write the answer the correct way, 8 times 10 to the negative 5 is greater than 8 times 10 to the negative 8. Now, some of you may have already known that without writing all of this out. For those of you who are still trying to understand this and get your mind around it, essentially the bigger exponent here makes it a smaller number because it's a negative exponent. Alright? Okay, that's it for this lesson. If you had any trouble, go back and rewatch the video or come see me for help. Good luck, and we will see you in math.